Okay, hello everyone, and welcome to our second workshop, which is an introduction to SPSS. So, in today's session, I would provide a brief introduction on how to download SPSS, and then we will talk about some basic statistical concepts related to descriptive statistics, such as mean, medium, mode, and standard deviation. And we will also cover some basic concepts related to inferential statistics. And then we will finish off with an activity where we will input some data into ANSPSS and we will conduct some descriptive statistical analysis. So SPSS is a software we commonly use in psychology to conduct statistical analysis. So in order to get access to SPSS, you need to uh, go in the software hub by the University of Essex, and you need to use your University of Essex login details. A kind of this is a bit of some students get a bit confused here because they use the logins that they use to log in into Moodle, which is a bit different from the ones that you need to log in the software hub. And it's the same that you use to log in into the University of Essex online library. So here we have a couple of how-to guides. So if it is the first time you log into the software hub, you need to go through a process to download Apps Anywhere. And once you've done so, you go through a validation process. And then basically you have access to all the softwares available through the software hub. And it's more than 100 software. Obviously, you're not going to need all of them, but they're there if you want some of them. Some of them is more generic. They're not all related to psychology. So we suggest that when it comes to SPSS, you download version 27. And you can see on the bottom of this slide, there is a license code. So when you go through the process of downloading SPSS, in the end, it's more likely to ask you for a license code. What happened lately, I have few students that I've supported with downloading SPSS, and they didn't actually, when they download the software, they didn't ask them for the license code. And that's because if you have a newer laptop or PC, it kind of happens automatically, and especially with version 27. So don't get panicked if you're not asked to put the license code. That's the reason why. So all the information here and the how-to guides, either software hub getting started or SPSS download guide, we have them available in the new module, which is the Psychology Technical Hub. So if you go through the different kind of, I think it's under the software, you can find all the information there. But today what I want to do is actually go through, let me just share my screen, through the process of the things you would actually see when you log into the software hub. So when you log into the software hub, you will see something like that. So you need to put your login details here, so your username and password. You don't need to put your whole email address. You just need your username. And if this is the first time you log in into the software hub, you need to obviously accept the license agreement in order to be able to download the Apps Anywhere. And then you need to click, it's my first time using Apps Anywhere on this device. And then you will see another window like that. So which will state that your download has started. And you're either going to see on the bottom of your computer or laptop the process of downloading the Apps Anywhere. It might be on the top of your computer. It depends, again, the settings. So once that's completed, you double click that icon and then you go through the process of installing the software. So you press run or you press next until you complete, and then you get something like that, installing apps anywhere. So once that's completed, you're basically ready to go. So you go through the validation process, you wait a little bit, and then you see a green kind of um like in my case, it just pops up a green kind of window which says validation process successful. So again, it depends on the type of computer or laptop you have. And then you're ready basically to access any software available by the software hub. So if you want SPSS, where it says search apps, you just type SPSS and you see the different version of SPSS available, which is 25, 27, 28. As I said, we suggest version 27, but sometimes you might be able to download SPSS version 25 because it might be certain kind of um, limitations, let's say, with your computer or your laptop. So that's absolutely fine. So what you need to do is to press launch. Oops. And then it goes again through the validation process. And then what you see, it's this window, which is Cloud Paging Player. So you see in the status, should tell you the percentage of the process, let's say that downloading SPSS1, that's ready. When the stage says ready, you just press the green arrow, which is launch, and then you're ready to go basically. So you'll open the SPSS, it might take a while, and that's where they may ask you to add your license code. As I said, it might not be the case within your version, so don't get alarmed with that. So that's basically it when it comes to the SPSS and how we download them. Let me just close that. Let's go back now. Okay. And let's start with some core statistical ideas. So when we collect data, and from our previous workshop, we know that the type of data we have, they're either nominal, ordinal, interval, or ratio. We want to see differences, similarities, and association between those measurements. So for example, we might be interested to see whether certain personality traits associate with certain behavior patterns. Or we might want to see whether taking, for example, a drug A or drug B has a difference in the depression level. So we collect data because we want to see, we're interested to research things that we observe around us and things that happen around us. And that's the main kind of idea why we do research. We want to find those answers. So the first step when we collect data is to show what this data look like. So, and a key for this is effective communication. What we mean with that, we need to be consistent with the way we present and communicate about our data. So when we start collecting data, we have measurements from every participant that we have tested, that they have taken part in our research. So when you think about it, if somebody comes and asks me, so what was the main outcome between, for example, drug A and drug B when you research, when it came to depression level? If I start saying, well, my participant one took the drug A and there was an improvement in his depression level, or my participant two took drug B and there was an improvement in her depression level, and imagine I have 100 participants, that will be very complicated for somebody to understand actually what the main outcome of my research is. So the best way to show other people what our data look like is to show the main point of those data and measure how they're distributed around this midpoint. So what we mean with midpoint measures? We usually assess the midpoint measures with the mean, median, and mode. So the mean is the average score. So we can calculate the mean by summing all the numbers and divide them by the total number in our data. So if you have, for example, some data such as 2, 2, 3, 5, 5, 7, 8, we sum all these numbers together and we have, because we have 7 values, we divide that total number by the number 7. So our mean value is 4.57. The median is the number in the middle once all the numbers have been arranged from the lowest to the highest. So if we have, for example, imagine we have data set like 8, 9, 7, 3, 3, 6, 1, then we arrange them from the lowest to the highest. So we go 1, 3, 3, 6, 7, 8, 9, and the median is the middle one. So it has equal numbers above and below that value. And the mode is the most common number in a set of numbers. So if you have, for example, a data set of 6, 3, 4, 4, 7, the mode is number 4 because it's the most common number in this data set. So these are different ways to present the midpoint measures of our data. Dispersion now, it's essential to show how numbers vary around the mean point. So the ways to do so, we have different ways. So we have the range. So it gives an idea of how far apart the most extreme responses are. And it gives you the spread of the whole data set. So for example, I have some responses 2, 2, 3, 5, 5, 7, 8. We range them from the lowest to the highest. We take the highest value and we subtract the lowest value. So that will give us a range of 6. And we also have the interquartile range, which tells you the spread of the middle half of your distributions. So the quartiles divide the data set into 4 groups. So each group in theory contains approximately 25% of the data values. So we have, for example, the 25th percentile, the 50th percentile, and the 75th percentile. So the interquartile range is the values between 25th and 75th percentile. So it's the values in this case between 30 and 19. And finally, we have the standard deviation, which is the average deviation difference of each score from the mean. So every score is involved in the calculation, indicating how far the average participant deviates from the mean. All these measurements, and we're going to go, obviously, I'm describing a little bit more how we calculate them. SPSS does all this calculation for us, so we don't have to, you don't have to panic that you have to do this by hand. But I think it's very important you understand how we get those measurements, how we calculate them, because then it'll be easier to understand what its kind of measure means. So when it comes to standard deviation, a small standard deviation would indicate that most scores cluster around the mean score. So participants, in essence, they perform quite similarly, whereas a large standard deviation would suggest there is a greater variance in the scores and that the mean is not representative because we have a lot of variation. So these are some concepts that we're going to assess later on in our workshops. And when we look our raw data, we want them to be a lot of the assumptions of the statistical test we're going to use. They suggest that the data need to be normally distributed. So one of the assumptions is that we expect 28% of all our scores to fall within one standard deviation of the mean. So how now we calculate the standard deviation? As I say, it's not something you need to do by hand. Let me just share my but I think it's important you understand how you do this. So this is the formula to calculate the standard deviation. So imagine, for example, that Sam has 20 rose bushes. So the number of flowers in each bush is 9, 2, 5, 4. So we have some raw data. Okay. So we want to calculate the standard deviation to see related to the number of flowers that its rose bush has. So to do so, first we need to calculate our mean. So we sum all those numbers and we divide them by the 20 number of rose bushes that we have. So our mean value is 7. Then what we do, we take each number of flowers that each bush has, and we subtract the mean value, and then we square that value. So we get a new data set, really raw data, which is 4, 25, 4, 9, etc. And then what we do with this new data set, these new numbers, we do the same as we did with our mean. So we sum them, and then we divide them with a number of bushes that we have, which is 20. So the sum of these numbers is 178, and we divide them by 20. So we get the number 8.9. And then what we do, we square root that number, so we get our standard deviation. And that's basically how we calculate our standard deviation. So let's carry on. So detailed descriptive statistics, means and standard deviations can only be used with real numbers, such as interval or ratio data, whereas ordinal numbers can be summarized with a median and a range, but not mean and standard deviation. And nominal numbers can probably only be summarized with mode. Here I have a link to the different types of data we actually went through in the first workshop. So if you have more, if you're unsure about the different types of data, we suggest to go and watch the first workshop. So just to summarize or go through very briefly about the different types of measurements and data we have interval or ratio, and they can only take any value within a given range, such as temperature and speed, and in SPSS they called scales. And the ratio scales have a true value of 0. Ordinal data can take certain discrete values within a range. So for example, position in arrays, or we commonly use them in Likert scales. So in SPSS is named as ordinal. And finally, we have nominal data, which is the values represent categories such as gender, occupation, and in SPSS, they're also named as nominal data. And categorical data can take numeric kind of values, but the number are meaningless. So we can assign any basically number to our categories. So when we talk about describing your data using different ways of summarizing them, descriptive statistics for summarizing the numbers you've collected. And this is the first step when we look at raw data. But we want to make more sense of our data, and that's where it comes inferential statistics. So inferential statistics make general assumptions of the sample population we collected data from and inform the general population. And why we do this, because when we do research, we cannot collect data from the whole population we're interested. So for example, if we're interested in assessing cognitive abilities in children aged between 5 and 6, we cannot assess all the children around the world aged between 5 and 6. So we need to take a sample and use inferential statistics to make assumptions based on our sample population. So inferential statistical tests allow us to assess whether there are differences between or within our conditions, and thus we can use tests like t-test or Mawinnet test, or whether we can assess whether there are relationship between our data sets, and thus we use tests such as correlation or regression. For each type of inferential statistical test you want to perform, there is a parametric and a non-parametric. A parametric test works with specific assumptions. So whereas a non-parametric one does not have the same requirements, the exact requirements are as the parametric. And that's why normally the parametric tests are more powerful. So because we're based on this specific assumption, we can be more sure that the conclusions we will make based on our sample for the general population are more valid and reliable. Another core statistical concepts are the independent and dependent variables. So when we do research, the variables we manipulate are called independent, and the variables we measure to assess the independent effects on are called dependent variable. So when you think about cause and effect, the independent variable is the cause and the dependent variable is the effect. So let's have a look at an activity. So we have a clinical practice and we want to assess whether a patient different innate and depression scores based on their gender and the type of therapy they have received. So here I have some data which I'm going to open and share with you. Just a second. So we can see we have participant 1, we have age, we have gender, we have therapy type, and we have depression score. Okay, so we have how many participants? 15 participants. We're going to use this data set to input the raw data in SPSS. So from what you can see, we can have 1, 2, 3, 4, 5 variables we're going to input in SPSS. And our main kind of variables are age, gender, therapy, and depression score. Let me just open my SPSS. Before we do so, what we want to do, our independent variables in this data sample is the gender and the type of therapy. And our dependent variable is the depression score and the age. So we're going to input some data in SPSS. We're going to code some missing data we have. And once we input the data, we're going to find the mean standard deviation, and we're going to conduct some frequency analysis for nominal variables. And we're going to do that based on the gender and the type of therapy. So let's go and open our SPSS now. Just a second. Okay. All right, let me just share my screen with you. And we're going to input some data. So when we open our SPSS, we have the data view and we have the variable view. Just a quick reminder from last workshop. In the variable view here, in each row, we put the different variables we have. And then once we define the different kind of values associated with each variable, we go to the data view and we put our raw data. So here, each column, it's a variable, and each row, it's a response from each of our participants. So let's go and start inputting then our data. We have participant, then we have age, then we have gender, we have therapy, and then we have depression. Okay, so, oops, I have a wrong depression. Okay. The type, as we click here, we can see we have different variable types. And the most common ones are the numeric, and sometimes we might use string when we want, for example, to input the name of our participant or something like that, something to do with letters. At this moment, all our variables are numeric, even the ones that are categorical, because we're going to define them using numerical values. So the width and the column is about how wide and narrow we want to be, especially that relates with string variables. And obviously how wide we want the column to present here if there was a string variable. Decimals, we can change this as well by clicking here how many decimals we want our values to be presented in the data view. We can change this as well. Labels, we can add more description related to a variable. So for example, age, gender, type of therapy we can put. Here we can input anything, whereas in the name we're quite restricted in the characters we can use, and the type, for example, we can put the space. If you see, if I put a space, it would say it's illegal character. So we have quite a restrictions about how we would name our variables. Values now, so here is where we define when we have nominal data. So let's go actually first in the role can be ignored, as I said previously. Let's go and assign our measures. So the first one is ordinal. So we have 1 to 15. Then the age is scale. Then we have gender, which we have different categories. So it's nominal, the type of therapy nominal. We have 3 different types of therapy. And we have our depression score, which is a scale as well. So missing values, we're going to come back to this, and we're going to define in SPSS certain kind of missing values if we have any missing values in our data. And that's what we need to do for our data. So let's go and input some raw data: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if you see here, when I say about the decimals, so you can put it like to 0, and you can see we have no decimals. Then we have 8, we have 30, 45, 23, 18, 50, 47, 32, 19, 51, 27, 26, 39, 21, 43, 38. And then, of course, I didn't define, that's my mistake, the gender, because we have different values. We have male and female. We have 2 categories. So we first need to define. So we defined 1 for male. And then I click add. And then I click 2 for female. Then I click add. And then I come to my data view, and I'll add the gender. So the first is male, which is 1. The second is female, 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 male, female, female. Then I have nothing, a missing value. I'll come back to this. Then I have male, male, female, male, female, male, female. So we have a missing value here. So what we have to do, we need to come where it's in our gender variable, and we need to define our missing value. So we go to discrete missing value. I will normally assign the value that it's impossible for our data to have the value, and sometimes like -99, -999. So you need to define a value that you know that your raw data doesn't really contain that numerical value. And we click OK. And then we come where is the missing value, and we'll put -99. So now SPSS know that this kind of value is missing. Then we come to our type of therapy. So we have 3 types of therapies. So we need again to come to our values and define the types of therapies we have. So we go for 1 for psychotherapy. add. 2, 4, I think it's antidepressant, so I'll put medication. And 3, there's no therapy, no treatment. Okay, so I define my 3 categories. So then I go to my data view and I add my raw data. So the first one is psychotherapy, 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 psychotherapy. Then I have antidepressant, antidepressant, medication, sorry, and then no treatment. And then I go to my depression scores and I add the scores 75, 27, 32, 30, 29, 27, 32, 35, 36, 38, 55, 57, 60, 51, 57. Don't forget to save once you input all your data. Don't forget to save your data. Oops. So we go here. I'll just save it as it is. Then we have a new window, which is the output, which is the viewer window, which is all our analysis will be there. So the first thing we want to see, it's, and you remember when it comes to nominal data, which is our gender therapy, we might want to see the frequency percentages of, let's say, male, females, and the type of therapy, let's say, that our participants had. So to do so, we go to analyze descriptive, and then we go to frequencies. Oops. And then we press type of therapy and gender in the variable views. Then we do statistics. I don't want any of this. I just want to see, let me just show you the output. So that will give me the kind of main percentages of each type of therapy. And also for the gender, and you can see here it score also the missing value. So for example, from our sample we have 33%, 33.3% they had the psychotherapy, 33.3 medication, and 33.3 they had no treatment. And we had 40% of our sample were male and 53.3 were female, and we have 6.7, which one participant missing. Participant, we don't know the gender. Okay, we had a missing value. So now we go back and we want to find the mean values, the standard deviation, and all these descriptive statistics that we're talking about. But we want to do that for age and depression. Okay, but we want to do that based on our 2 different categories, the gender and the type of therapy. So in order to do so, we go to descriptive statistics and then we press explore. And we put in the dependent list age and depression. And then the factor list, we put gender and type of therapy. And then we'll click our statistics. I don't want any of this. Then we could click plots. And we click histograms, normality plots with test, and then we press OK. And we will get some nice output now. Let me just share this. There we are. So here we have the number based on gender. Okay, so we have the number of female and male. And we are looking at the descriptive statistics based on the gender. But we look at the age first, okay, our dependent variable age. So for males, the mean age was 40. Standard error we have here. We have the confidence interval. We have the median value, the variance, the standard deviation, minimum and maximum values, range, interquartile range. These are all important things when we first make sense of our data, okay? And some of these values you might report in your output. But when it comes, as I said previously, we also are interested at this stage. So any kind of statistical test we do, the first thing we do, we check our data, we do our discrete statistics, and we check whether our data are normally distributed or not. So the first thing to check whether our data are normally distributed or not is to check the skewness and the kurtosis. And how we do that, we want values to fall between minus 1.96 and plus 1.96 for both skewness and kurtosis. So what we do, we take the statistic value for the skewness and we divide it by the standard error. And we need to do that by hand. And then we assess whether the outcome of this value is between those ranges. So that kind of the first thing we can check in our data. Then we have the same kind of output for our female based on the age. And then we have our depression level for males. And then we have depression level based on our females. And then we have our test of normality. So we have the Kolmogorov-Smirnov and the Shapiro-Wilk test. The Shapiro-Wilk test is commonly used when we have let's say our sample is less than 50 participants. So the null hypothesis for the test of normality is that the data are normally distributed. So in any kind of statistical test that we do, we want our p-value, which is the significant level, to be, let's say, no, we want to be, but let's say for our results to be significant, we want the p-value to be less than 0.5. So in the test of normality, it's kind of the opposite, because the null hypothesis suggests that there's a test of normality, that the data are normally distributed. So the null hypothesis will be rejected if the p-value is less than 0.05. If it's not, then we accept it, which means that our data are normally distributed, which means that we want the significant level to be above 0.5, and thus we can argue or say our data are normally distributed. So what we can see here, for the depression level in the females, we can see that our data are not normally distributed. For all the other measurements, it seems like they are actually normally distributed. And we can also check our data. We can check the histograms and check about the normal distributions. We can check the QQ plots and what we want. We want our data to be around this line. So we want them to be quite close together. So we can see for males and the age scores, we can see they're quite normally distributed. So there are different ways of visualizing the data, and that's why important in the descriptive statistics. It gives us a kind of indication where it's the best kind, it's the first kind of assessment of our data, whether how they look like, are they normally distributed. This will be important because a lot of parametric tests, they have so a lot of statistical tests, parametric tests, they have assumptions related to normally distributed data. And then we have our, yes, let me just go down. QQ plots, and then we have our output for the type of therapy. So before it was the, I think it was a, I forgot, sorry, it was the AIDS. Now we have the type of therapy. It was a gender, sorry. It was a gender, now we have a type of therapy. So we have the psychotherapy, medication, and no treatment, and based on the age and depression. And again, we have the same kind of output. So for the psychotherapy, the ones that they had psychotherapy, the mean age was 33.2. Then we have our median, variance, standard deviation, etc. We check the skewness, kurtosis to be within the range minus 1.96 plus 1.96. and we have to do it by hand. We take the value of skewness, the statistic value of skewness, and we divide that by the standard error of the skewness. And we have for all the 3 treatments, and then we have the scores for the depression, okay, the ones that they have psychotherapy, the ones that they had medication and on treatment. And we check the normality test. Again, we can see all our data are normally distributed. And then we check our histograms again and our QQ plots, and we make more sense of our data, and we can decide about all these kind of different factors, whether our data are normally distributed or not. That's it for today. Thank you for listening. What I wanted to say, I'm going to upload this workshop. It is important you follow each one of the workshops, because if you haven't really attended or listened to the first workshop, some of the things that we cover in the second one might be new to you, so you might feel a bit lost. So it's very important you follow up each one of the workshop. Thank you very much, and I see you all soon. Bye.